Hi all, this is Scale 12, Simplifying Rationals. We're going to be working on higher order. We first want to remember just this idea of our exponent rules, or our radical rules, is what we've dealt with this time because we're dealing with radicals. So if I have a root or a radical going over various variables or constants on the inside, I can write them as two separate radicals. If I'm dividing two things inside of a radical, I can write them as two radicals divided. And this is going from exponential form to radical form. So we're going to keep that in mind as we begin. So we first want to think about whatever number is here, or whatever number is, if we look at the formal, if we scroll up and look at the formal definition, that is the index. So my index is 2 here. That tells me what I'm grouping and how many groups I want. So I did step 1. I identified the root is 2. Now I want to break radicands into simplest parts. So I can write 4 as 2 times 2, and I can write x to the 6. As 6 x's. So now I want to group by 2. So I'm going to make as many groups of 2 as I can. 1 group of 2. Okay. Anything that had a group of 2 gets to move to the outside of the radical. Anything that doesn't get a group stays inside the radical. So I end up with 2x to the 3rd. So this was asking us for groups of 2. This one's asking us for groups of 3. My index is 3, so I'm going to write everything as prime as I can. Now I'm going to group by 3. One group of A gets to come to the outside. One group of B gets to come to the outside. Another group of B. If it's helpful for you to write, like, there was nothing left on the inside or square root of 1, that's fine. If it doesn't help you, that's fine. So this is root, or groups of 4. So I want 4 x's, 8 y's, and 2 z's. Now I'm trying to group things by 4's. So I have one group of x's gets to come to the outside of the radical, or radicand. One group of y's accidentally miscircled, another group of y's. Now if it doesn't make a group of 4, that means it's going to stay inside the radical, or the radicand. Okay, so these are simpler ones that helped us see what we're grouping by and how the index tells us what we're grouping by. So this is truly what a square root is. So these get a little bit more complicated. This is a group of 3. Square root of -3, or -37 can be written as -3 times -3 times -3. I have 6 C's and 1 B. I'm making groups of 3. Sorry, that should have a negative in front of it. So I had a negative 3 can come out of the radical, a c, and another c. I don't have 3 b's, so the b is going to stay inside. So this next one is a little different in the sense that we have division. We're going to remember the theorem, or the properties, that I can write this as 25/50. I can divide those both by 25. And continue to simplify as I then apply the rule again and write them as 2 separate fractions. I want to get rid of the radical in the denominator, so I'm going to multiply both the numerator and the denominator by square root of 2. Yeah. And then I cannot simplify this any further, so that would be my final answer. Okay, for F, there's a couple ways to think about it. We can write it as 1 fraction and try to simplify. And it's asking for groups of 4. Sorry, I should have marked that. And then when I simplify 64 and 256, this becomes 4th root of run over 4. I can have 5 m's. So then what we group what we can by 4s. So in the denominator I can have an m and n squared. But I'm going to now write this as 1 to the square root of 4. The 4th root of 1, which is still 1. And the 4th root of 4 n squared. And if I want to get rid of the n, the radical in the denominator, I need to multiply by what I currently have in the denominator that's in the radical. So I'm multiplying by a fancy 1. My new numerator is 4th root of n squared times 4. In my denominator, I now have m which would come out to be that. We will have time in class to practice and answer any questions. Thank you guys for following along.